doing. So, this is actual data. Oh my gosh. Okay, guys, we gotta do this. Okay. So this is actual data. This happened long before any of you were born, but this is actual data from 1999. 59 tornadoes hit Oklahoma in the same day. And no. Okay, so what's recorded here, these are the ones that were the strongest. So there's 16 of them here. And this is, the intensity is not important. I just included it on the table if you were interested. But this is the length of the path that the tornado took. So literally, like, each one of these is in miles. So like a 6-mile path of destruction for the tornado. So as you can see there, these get, if you read some of those data values, they're not in any particular order. Some of them are really, really long. So I'm going to show you guys how to calculate like mean, median, and not mode from the calculator, but mean, median. The calculator will do all of these except for the mode and the interquartile range, but if you have the information above that, you should be able to figure those out. So I'm just going to go through with you real quick and show you how to put this in. Okay, so first thing you're going to do is you're going to hit your stat button, which is going to be kind of in the middle, like underneath the zoom. It's like the third button down. It says stat. You're just going to hit that. Now, the menu that's on says edit right next to it. And so you're not going to do anything there except hit enter, because we do actually want to edit and we want to put the data in. And it should take you to a screen that looks like this with a bunch of columns. Now, just real quick, if you have any data in here, so if you have something in the column, if you just arrow up to the top here real quick where it says L1 stands for list 1, hit clear and hit enter, that would get rid of any data that might be in there. So if you've got data in here, just arrow up to the top, hit clear, hit enter, and that should wipe it all out. Now, if you accidentally, like, don't use the delete key to do this, but if you accidentally hit the delete key, it will literally delete the whole column. You don't want to do that. If you accidentally do that, you just hit stat, and then the 5th button down there says set up editor. That'll just reset that screen. So if you do accidentally delete something you don't want to delete, just go back to stat. Number 5 is set up editor. That'll reset it. Okay. Now, once you're here, what you're going to do is in the list 1, you want to type your data. So you have to hit enter in between each one. Sorry, there's 16 of these, but I'm just going to type these in. And this way we don't have to put them in order ourselves from least to greatest to calculate the median and all that kind of stuff. So I'm just doing this, and we're going to let the calculator calculate our data values for us. And usually when I do this, I'll just go back and check just real quick, make sure I didn't mistype anything or flip any of the digits or something like that. They don't have to be in a particular order, so if you missed one, you can go back and add it at the end if you want to do that. But just make sure you got all your data values in there. And once you do that, you're just going to hit that stat button again. And this time when you do it, after you got the data in there, you're going to arrow over across the top. There's a menu that says calc, that's to calculate something. And there is a bunch of different options in this menu. We're literally just going to use the very first one. So it should say like a 1-var stats. Just hit enter. All right, so that stands for one variable statistics, because we just have one thing we put in there, which was those tornado path of damage lengths. Now, if you have this on your screen, it should say list 1, because that's where we type the data. If it doesn't say list 1, it's really easy to fix. You just, you can clear that and just hit second and then the number 1, and then that will put list 1 in that place. So if it doesn't say list 1, that's what you want to make that say. If it already does, you're just going to keep hitting enter until the data shows up for you. Now, if you guys remember from yesterday, that first little symbol is called X bar. That is the mean of the data set. So this is, I'm just going to go like 2 decimal places here. So this is about 2.81 miles, since we're talking about the miles of the tornado's path here. And then there's a lot of other stuff here, and we will use this in the next couple of days, but for the moment, if you just use the down arrow key, just scroll all the way to the bottom, Really the only thing I'm going to take from the top of that is the mean, and the 5-number summary will be at the bottom of that list. So the N here is just the number of data values. So there were 16 tornadoes, so that's all that's saying. And then it says min X, so that's just the minimum value for the data set is 1. The Q1 is the 6.5. The Q2 is also called the median. So median is going to be 8.5. Q3 is 15, and the maximum is 39. But that, I mean, you can see the minimum and the maximum probably pretty quick on the data set. But to calculate the mean and the quartiles, the calculator doing that for you should save you some time. Okay, now the calculator will not give you the mode or the interquartile range, so we're just going to see if you guys remember that from yesterday. Would you say, is there a mode or modes for this data set if you look back through it? There's actually 3. 7 is one of them. 15 and also 8. So yeah, you guys got it. All 3 of those appear twice on that list. So since there's a tie, they appear multiple times. If there's a tie, there can be more than one mode. So each of those data values appears twice. So we got 3 modes. Now, yesterday, I think I mentioned this, but we didn't really spend a lot of time, but we will need it today. So the IQR stands for interquartile range. And to calculate this, it is Q3 minus Q1, the third quartile minus the first quartile. Okay, now I'm not trying to be confusing. I probably should get a different data set here, but if you take 15, in this case, minus 6.5, you get 8.5, which is the same as the median. It's just kind of a coincidence. That doesn't normally happen. So I'm not trying to confuse anybody, but the interquartile range and the median do end up being the same value on this. Okay, now we're going to talk about outliers today. And you guys could probably get a feel for this, but the definition is just a data value, or it could be more than one value, that's just really different from a lot of the rest of the data set. So if you were looking at that list, are there any numbers on there that you might lean towards being an outlier for the data set there? Okay, so Ryan says maybe 39. Okay, question mark. Now, sometimes I'll look at a data set and think something is an outlier, but maybe it's actually not. So there's an actual formula for how to calculate that, and that's what we're going to get into underneath here. Okay, so, and just in case you guys see this, I'm going to write this down. I call these a lower bound and the upper bound. Some people call this a lower fence and an upper fence. I will likely not use that terminology at all because I literally just heard it in a meeting this morning. I was like, what are you guys talking about? Anyway, there's an actual formula. So you're going to exclude any numbers. There's 2 different categories, one for the lower end and one for the upper end of the data. So on the lower end, the formula is whatever your first quartile is minus 1.5, which is literally part of the formula, times the interquartile range. That's the formula for it. So any number in your data set that would be below that value, we would exclude. And on the upper end, it's the third quartile plus 1.5 times the interquartile range. Any number above that value is going to be an outlier, and we would want to exclude that from our data set, which we're going to do here in a second. Now, for our example up here, all right, on the lower end, our Q1, if you look back to what we grabbed from the calculator there, this was 6.5 minus 1.5 times the interquartile range. I am not using the median there, and I'm not trying to confuse you, but it just ended up being the same number. All right, so I'm just going to do 6.5 minus 1.5 times 8.5, and you guys can probably tell, hey, Miss Brody, that's going to be a negative number, right? So I would exclude any data value that was below negative 6.25, but if you look at our data, we don't have any negative numbers. So on the lower end, there's no outlier because there's no number on our data set below that yet. If you do 1.5 times 8.5, right, that's like, it's 12.75. So if I do 6.5 minus that, because you got to do the multiplication. No, that's a good question. You got to do the multiplication first, but it ends up being negative. You can type it right into your calculator, but that's how it ends up being negative. Because 1.5 times 8.5 is a little bit bigger than the 6.5. Good question. Okay, now on the upper end, now this one's different. So this is Q3 plus 1.5 IQR. So on the upper end, we're going to do our Q3 is 15 plus 1.5 times 8.5. So this one should be positive. And you guys, honestly, you could just type it right in if you want to do it, just plus 1.5 times 8.5. Your calculator in that scenario will follow the order of operations and do that multiplication first and then add it to the 15. Okay, so then I got 27.75. So any number that's above that, any number on the list, which there's actually two. If you look through that list, 39 is one of them, but there's also one of the tornadoes was 37 miles. So there's actually two outliers in that data set. Okay, so outliers can kind of skew data in one direction or the other. So we're just going to, real quick, we're going to remove those and recalculate our 5-number summary here because you can see the effects of the outlier on the data, how it's going to stretch it. Okay, so to do that, I'm just going to remove my outliers. We already have this data set in here. So if you want to just hit Stat, we're going to go to the Edit. Okay, now I'm just going to remove the outliers. You don't have to retype the whole thing. Just bring your cursor down to like the 37, and then I am going to hit the delete key to delete that out, just the 37. And then I'm going to arrow down to the 39, and I'm just going to hit the delete key and just delete that out. So I just got rid of the two outliers that we calculated. Okay, so now once you delete the two outliers, and if you deleted more than that, you can retype stuff in here, it's fine. But go back to Stat, and we're going to recalculate the statistics for this. So it's Stat, you arrow over to the Calculate menu, and then you want the one variable statistics, and then just keep hitting Enter till it shows up. Yeah. Okay. All right. Hopefully yours looks like mine. So I'm going to rewrite this here real quick. So my new mean, originally it was 12.81 miles. I'm just going to go 2 decimal places. Now my average is about 9.21, which is more representative of the data because we had those two outliers. So that's a little bit better prediction. Okay, now if I come down, I'm just going to scroll all the way down to the bottom. That 5-number summary, the minimum is still the same because we didn't have any outliers on the lower end. And Q1 is now 6. The median, which is Q2, is 8. The third quartile is 13. And now the maximum is 22 because we removed those outliers. So what I'm going to have you guys do, I'm just going to come down here. And I'm going to draw box plots for both of these with and without just so you guys can see the difference. So on the top number line here, I'm going to do it with the outliers included. And then on the bottom one, I'm going to do without. And you're going to see how those can affect the data. Now, the number line is huge here. It goes all the way across, and it does go by ones. So for the original set of data, the minimum was 1. So I'm literally going to start right there. And then just kind of estimate these. So Q1 was 6.5. So I'm going to draw kind of like a vertical line best I can between the 6 and 7. The median was 8.5. So I'm going to draw a vertical line between the 8 and the 9 best I can. Q3 is 15. So I'm going to try and draw that on the 15. And then those 3 vertical lines, I'm just going to draw a lovely rectangle around. You can connect that to the whisker at the other side you can. Now, the maximum, all the way across here at 39. So all that data is spread across that entire number line if I include the outliers. Now, if we remove the outliers, I'm going to use the data that you guys can see up on the screen that we recalculated there. So my minimum is still 1. But my quartiles and my maximum are all going to shift just a little bit. So my new first quartile is just right on 6. So it's just shifted a little tiny bit to the left. My new median is 8. Again, just shifted a little tiny bit to the left. And then my new Q3 is 13. So that's shifted to the left 2 full spots. And what's going to be really shifted is your maximum. So my maximum now is only 22. And so the second one, when we remove the outliers, is a better representation of the data as a whole. Is anybody having a question? Okay. Now, on the back, we're going to do kind of little side things. So this is a little different from what we were doing with the data set. We're going to do percentiles on the back here real quick. Okay, so you do want a calculator for this, but it doesn't have to be a graphing calculator. It's not going to be a menu we're going to use. So percentile. This is another way to break the data apart. This breaks the data apart into 100 different units versus quartiles, where we just do 4. Okay, so a percentile has to be a number from 0 to 100. Okay, you can associate with the value, it says X from a data set. Okay, percentile shows the percent of the data that are less than or equal to X. So, like a good example I could think of this, like a lot of times, if you're a little kid, they take you to the pediatrician. They do your height and your weight, and they'll say, okay, well this person, my little example says 90. So let's say I take a little kid to the doctor's office and they say they're in the 90th percentile for height. What that means is they're taller than 90% of the people their age. If I go to the doctor and they say they're the 60th percentile for their height, that means they're taller than 60% of the people their age. So that's how that works. So we're going to talk about 2 different ways for calculation with this. So how to calculate what data value is a given percentile. Okay, so we're going to do this one first. So you're going to take whatever the percentile is. So if they tell you like the 75th percentile, you're going to take 75, all right? But you want it as a decimal. So again, if they said 75th percentile, I would do 0.75, okay? You are going to multiply that number by the number of data. I'm going to just write in the set. So you'd have to have a set of data. So you're just going to multiply by how many data values you have. So we're going to, our little example here we're going to do, I've got 25 test scores, so I'm going to multiply by 25. And what you're going to look for there is the place, or sometimes they call this the position. Okay, now, sometimes that number is not a nice number, and no matter what the number is, no matter what, you have to round down, no matter what. If I got 29.9, I have to round that down to 29. So it's not normal rounding, you're going to round down. We're going to do a couple examples here in a second. But to start this off, and I'm really sorry, I know this is a tiny bit annoying, you have to number the data. So in this list, I've got 25, and they are in order from least to greatest, so you don't have to do that. But I'm going to literally like write 1, 2, 3, 4, 5, 6 underneath each one of these. And I promise if I give this to you guys on a test or quiz or whatever, I will put them in order so you don't have to do that on top of numbering them. But I am going to number these. And there should be 25. No one got 100 on that test, apparently. Okay, so calculate the 90th percentile. Okay, so 90th percentile you guys would think of as 90%, right? So what would that be as a decimal? 0.9, right? So you're just going to take 0.9. Now, in our set, I got 25 test scores. So you're going to multiply that by the number of data in the set. So that'd be 25. And if you do that, should get 22.5. Now, sometimes you get a nice number, sometimes not. It just kind of depends on the question. But what I want to do here, no matter what, like normal person would round that to 23 if I told you the nearest whole number. If you're working with percentiles, you absolutely have to round down. And you're going to look for the 22nd number in that line. All right, so if I just go here, I've already got them numbered. So the 22nd number in that line is 96. So my answer to this question, the 90th percentile, is going to be that person that scored a 96, scored better than 90% of the class, is what that would mean. So if I want to do the 20th percentile, I'm just going to do 0.2 times 25. Now this is actually a nice number. This is just straight up 5. So you just find the 5th position in that line, which is a 62. So in terms of the 20th percentile, that person that got a 62 scored better than 20% of the class. If you want to do the 50th percentile, I'm going to do 0.5 times my number of data values, which is 25. Now, this is another one I'm going to have to round. This is 12.5, but no matter what, you round it down. So I want the 12th data value here. So if I come back up to my list, that corresponds to 72. So then the person who got the 72 got better than 50% of the class. Is anybody having a question? Okay, now the other thing that you might be asked, they will give you a data value. They'll give you a test score in this example, and they'll say, what percentile is that? So, little tiny different formula. You're going to take the place or the position, however you want to say that, of your data value. So, like if I told you, let's look at the list and I'm going to look at 71. 71 is what percentile? That is in the 11th position, so the 11 would go on the top of this fraction. Okay, and then on the bottom, number of data in the set. This will actually give you decimal, so to get the percentile, you have to multiply whatever that decimal is by 100. Should just scooch the decimal place 2 spots. Okay, now, the reason I put this little asterisk here, if you guys look up at these test scores, there's a couple different people, like 2 people got a 68 or 2 people got an 88. If you have a score that appears twice or 3 times or 4 times or whatever it is, and they give that to you and say, what percentile is this? You always want to choose the data value farthest to the right when you're picking the position. So if a score appears multiple times, you want to pick the one that's farthest to the right in terms of what place or what position you're going to put on the top of that fraction. Okay, now I'm not going to be able to get this data set on the screen at this. Oh my gosh, I can't do this. Okay, scooch this up. Now, if you guys look at 70, where does 70 fall in the list? 10. Okay, so it's in the 10th place. So all you do 10 divided by 25, and then we're going to multiply that by 100. If you do that, you should get 0.4 times 100, so this would be 40, so that means it's the 40th percentile. You just got to figure out where in the list the position is. So if I do 93, like if I'm looking at the list, that's in the 20th spot. So it'd be 20 divided by 25, and I'm going to multiply that by 100. That should be 0.8 if you do that times 100. This will be the 80th percentile. Okay, now I'm going to pull this back down just real quick so you can see. 88 does actually appear in the list twice. There's 2 different people that got that score. So if I give you 80, say 88 is what percentile, you got to pick the one farthest to the right. So there's 2 positions here, 17 and 18. Pick the bigger position, so it's going to be 18. So I'm going to do 18 divided by 25. If you do that, you should get 0.72 times 100. So this one's going to be the 72nd percentile. And then just one more I did as another example real quick. A score that appeared twice was 62 up here. You got to pick the one that's farthest to the right. And we actually use this in another question. So when we use this, we calculated that as the 20th percentile, right? So my answer here, I do this, should be the 20th percentile if I'm doing this correctly. So I'm in the 5th position out of 25. If you divide that, you get 0.2 times 100, and that is the 20th percentile. And that's all you have to do.